All right. Example 8 is asking us to prove that NCR is equal to NC n minus R. So we're being asked to prove that NCR is equal to NC n minus R. Now, first of all, NCR is equal to n factorial over n minus R factorial R factorial. Also, n Cn minus R, the right-hand side would work out to be n factorial over n minus R factorial, factorial n minus R factorial. So our objective is to get the left-hand side to look like the right-hand side. Now, you'll notice in both the left side and the right side, we have n minus R factorial. So I'm not going to touch the n minus R factorial. Here's what I'm going to do. N factorial. For the R factorial, I'm going to, so I have what? N minus n plus R factorial n minus R factorial. All I did to R is to add n and minus n. So R factorial in bracket, all I did, I changed R factorial to n minus n R factorial plus R factorial, which is still what? R factorial, because n minus n is what? 0. Then what I did next is I factor out the negative 1. So I have n factorial over n minus R factorial n minus R factorial. And then now this, if you can see that this looks exactly like that. So this is equal to n C n minus R. That's all I did. So direct proof. Let's go to example 9. Example 9 is asking us to simplify NC3 plus NC4. Now, this is n factorial over n minus 3 factorial plus n factorial over n minus 4 factorial. So let's expand the numerator a little bit. N factorial is the same as saying n times n minus 1 times n minus 2 times n minus 3 factorial over n minus 3 factorial 3 factorial plus we have what? N into n minus 1, n minus 2, n minus 3, n minus 4 factorial over n minus 4 factorial 3 factorial. So these cancel. Thank you. So this should be 4 factorial. 4 factorial. So in the numerator, what I have common is n minus 1, n into n minus 1, n minus 2. So that is common. N into n minus 1, n minus 2. Sorry, I don't think I reached there, say it. If I'm adding or subtracting fractions and the denominators are different, I must find the LCM. What is the LCM of 4 factorial and 3 factorial? What is the LCM of 4 factorial and 3 factorial? It's 4 factorial. Three factorial into 4 factorial is 4. So it's 4 times the numerator. Three factorial into 4 factorial is 4. Now 4 factorial into 4 factorial is 1. So it's 1 times the numerator. I'm sure that there are other ways you could have done this. Now common in the numerator is n into n minus 1, n minus 2. N into n minus 1, n minus 2 is common in the numerator. If you factor that out, I'm going to left with 4 plus n minus 3. And this is over 4 factorial. This becomes n into n minus 1, n minus 2, and then this is what? N plus 1? N plus 1? And this is over what? 4 factorial. So I guess this could be the answer. This could be the answer. N into n minus 1, or if you want, put it in order. It's n plus 1 times n minus 1, n minus 2 over 4 factorial. What's 4 factorial again? 24 over 24. All right. Example 10. Example 10, I'm guessing, is a similar question. We're asked to prove that the left side is equal to the right side. We have n C2 plus n minus 1 C3, n factorial over n minus 2 factorial 2 factorial plus n minus 1 factorial over n minus 1 minus 3 factorial 3 factorial. We have n factorial, n minus 2 factorial 2 factorial, n minus 1 factorial, n minus what's that, 4 factorial 3 factorial. So let's do something similar to what we did before. Let us eliminate the n minus something factorial from the denominator. This is n times n minus 1, n minus 2 factorial over n minus 2 factorial 2 factorial plus n minus 1, n minus 2, n minus 3, n minus 4 factorial over n minus 4 factorial 3 factorial. These cancel. So we have n into n minus 1 over 2 factorial, which is 2, plus n minus 1, n minus 2, n minus 3 over 3 factorial, which is 6. If I'm adding or subtracting fractions and the denominators are different, I must find the LCM, which is 6. 2 into 6 is 3, 3 times the numerator. 6 into 6 is 1, 1 times the numerator. Common to the numerator and the denominator is n minus 1. Common to the numerator and the denominator is n minus 1. So we have 3n plus n squared minus 5n plus 6. And this is over 6. So the final answer here is n minus 1 times n squared minus 2n plus 6 all over 6. All right, since this was a proof, let's look and see if this was what is on the right side. Yes, it's exactly what's on the right side. So we just proved that nC2 plus n minus 1 C3 is equal to n minus 1 into n squared minus 2n plus 6 all over 6.